Okay, we've been talking about the history of the railroads in North America, and we're going through the brief history, and especially 1950 to 2020. We're starting with the BNSF. We went through the various components, and now today we're doing the Northern Pacific Railway, and specifically the diesels. Here we see a picture of FT, and again, this was the locomotive that really put diesel electrics on the map in mainline freight service. They'd been doing pretty well in passenger service and in small switching applications, things like that. But when General Motors came out with this before World War II, they took it on a barnstorming tour all over the country. And it just amazed the railroads at how reliable they were, how efficient they were to operate, and the lack of maintenance that was needed. They needed about 1/10 as many hours as a steam locomotive because they could run, for example, the Northern Pacific bought some because they can go from St. Paul to, they could run them from St. Paul all the way to Seattle, Tacoma, and then they could turn around, fill the oil and check the oil and fill them up and run them back. And they didn't need to go to the roundhouse, and they could do it again. And they really did very well, and they were 25% efficient as opposed to the steam locomotive. So I mean, you see this little fuel tank here. This will haul it, several hundred miles, as opposed to a locomotive tender, which of course has water too, and that's another big problem. So anyway, these are the units, and so the Northern Pacific bought a bunch of them. The other thing that General Motors did is the railroads had always specifically had their steam locomotives designed for them. They were, except for the United States Railroad Administration in World War, they came up with URSRA designs. It was pretty much everything was different. General Motors said, here's the FT. It was like a Chevrolet. You can buy them any color, but here's the FT, A and B, and that's what you get. And the railroads asked for special things, and they rarely would do it. It was basically with or without dynamic brakes or steam generators. So anyway, the Northern Pacific bought a bunch of FTs, and they would run them on their system, all over the system. Now, the other thing that happened after World War II is the small branch line passenger trains. This is a tourist train, but it's typical of a branch line passenger train that would run from various points. And they, as the highways developed and people had more cars, the traffic went down. And so they needed to have a large crew for a relatively small number of passengers and everything else. And they were expensive to operate, of course, because of the steam locomotive. And so early on in the 30s, Northern Pacific and a lot of other railroads bought these gas electric cars in the 20s and 30s. And this is, in fact, how Electromotive Corporation got started. They were building these gas electric cars. And basically, it's a long coach with a distillate engine or a gasoline engine inside the compartment up here with a generator, and then they had a type like a trolley truck in front with 2 traction motors, and then they'd have a post office section, a less than carload freight section, and then a passenger section. So this thing was self-contained, and because it was a diesel electric, gasoline electric, or distillate electric, but it was a motor and electric drive. They could pull a few box cars and a passenger car so like this is northern Minnesota on this little branch line, and so this was a fraction of the cost to operate of a steam locomotive. And so they bought a bunch of those. Well, they were starting to get a little bit older, and so after World War II, Budd Corporation came out with these stainless steel RDCs, rail diesel cars, and they sold them all over the country. And basically, it was a railroad car, stainless steel, with 2 Detroit Diesel 671 inline diesel engines, 71 cubic inches per cylinder. Very, very reliable, possibly one of the most reliable diesels, certainly at the time. And so then they had radiators, and then a couple of drive shafts went down, And then they had Allison automatic transmissions that would drive this truck and that truck. And they worked very well by themselves, very reliable, very low cost to operate. Some of the railroads tried to hang cars behind them, like they did the gas electrics, that like the Minneapolis and St. Louis. That did not work. The transmissions could not take the extra load of pulling a car. So Northern Pacific bought some of these for example, from Duluth to Staples, so they could connect with the Main Streeter, or from some of these branch lines here. Also, they would run them from Fargo to over here, and then they would wander up here to East Grand Forks, and then Grand Forks, and then they would wander like this up to Winnipeg. So the Winnipeg train eventually had one of these things on it. And so here we see it in leaving Fargo, heading off to Winnipeg. That's the Fargo power plant. And so these operated, here's a picture off the internet up near the border, heading to Winnipeg. So this was very low cost to operate, and so they could run these trains a lot longer than they would have otherwise. So anyway, back to diesels. After World War II, General Motors, which had been only able to build the FTs and a few E units, they could build SWs and NWs. And so they built the switch engines, and this is an SW1200. And Northern Pacific bought a bunch of these because they had a lot of yards and a lot of switching all over their system. And then they also bought, because they were hungry for diesels and they couldn't get, they were buying Alcos at the time too. And the Alco RS, this is an RS3. And it really is the first diesel electric road switcher. Alco had come out with the RS1, which is basically a switch engine with a cab in the middle, but it was only 1,000 horse. This was the first really road switcher, and it came out before the GP7. And they were very successful. Alco built 1,500 of them after the war, with BB 4 axles, 4 motors, 6 axles with 4 motors, which was a C RSC, and the RSD was 6 axles, 6 motors. And so they built a lot of these. I also include this picture because for the modelers, you can run any boxcars anywhere, no matter where your layout is, because you look at this northern North Dakota, here's a Detroit and Mackinac boxcar, a central of Georgia long boxcar, a B&O car, and Pensy and everything on back. And I think there is one NP car in the train. And this is a local up in northern North Dakota. And what's happened probably is material loads were shipped here from, say, Michigan. And then they probably kept the car because if it's in the fall, looks like it's in the fall, they were short of boxcars. So they would just keep the car, and they would pay the host road a per diem charge every day that they had it. So that they were out of cars, they needed cars. So it's an interesting picture. This is Duluth, and of course then they bought the General Motors GP7s and GP9s, and this was obviously GM's most successful locomotive. They came out after the Alco RS2 and RS3, but Dick Dilworth didn't want to design one of these things, but he said, okay, I'm going to design it. It's going to be so ugly, they're never going to operate. Most people think this is actually pretty attractive. So he put this kind of a wedge nose on it and a very clean lines on the car body. You can see it was basically an F unit in a car body. The F unit had 4 fans on the roof. And so they split the radiator in half, and they put half of it here and half of it there, and 2 fans on each side. And it was basically an F unit in a car body. But they were very popular with the crews. The railroads really liked them, so they sold a lot of these alongside the F units. And then they had built GP18s. They raised the horsepower to match Alco's RS, I think it's RS 11, the DL701. And so this is 1,800 horse. You can tell it's an GP18 because it has straight louvers here instead of the chicken wire that they had. And here's the Alco DL701, 1,800 horsepower. And the NP bought a slug of these things. General Electric had come out with the U25B. Well, then they came out with the U25C, and Northern Pacific has many more grades than the GN does. And so they said, and they have heavier trains. They also ran coal trains. So they said, that U25C looks pretty good. And General Electric had put a lot of advancements, more advanced control system, wheel slip. They also had a big thing they did was a very clean car body, tight car body, and they had two air intakes here with filters. So the engine compartment and generator were in a clean environment as opposed to the GP9s, which the NP, here's what the NP was running. They were 4 GP9s on a freight train, but you see louvers, that's just air blowing through the. So the NP bought U25Cs, and here's 3 of them early on with a dynamometer car, which has tensiometers in the couplers, and they can tell how much they're pulling, and they have all sorts of other sensors in the engine, and then the people back here are measuring the performance of the engines, but they really liked them. So they bought them, and they bought more. And then they also used them on the coal trains. This is after the merger, but basically it's a coal train that went from Montana down to Chicago area to Commonwealth Edison. And so there's about 400 miles on the Burlington and about 800 or 900 miles on the Northern Pacific. So that makes sense. You run 2 of these units, U25Cs, and then a U25C on the Burlington, and that kind of matches horsepower hours. And they had to keep track of the hours, obviously. But these did very well. But they found that the U25Cs didn't do as well over about 50 miles an hour. And so then they went back to General Electric and they bought U33Cs. So this is 3 of those. This is the postcard. It's a little pixelated, but anyway, then they went back to General Motors when General Motors came out with the SD45, and Great Northern was the first customer. 3,600 horsepower, 20 cylinder, 645 cubic inch engine per 645 inches per cylinder per power assembly, and 20 cylinders, V20, and they were very reliable, very good engines. A little bit of a fuel hog, but they really performed, and they did very well above 60 miles an hour. So they pulled that extra thing, and so this became the standard lash up in the late 60s for the fast trains. 1 SD45 and 2 of the General Electric U-boats. So here's a calendar picture, and this is number 602 coming east. You can see that it had gone westbound with an SD45, U25C, U25C, and now they turn around, they're heading back east with number 602. So out west, looking around, of course, they always had the semaphores. Took this out western North Dakota, and I was there with Carl, and this coal train. It's right after 1970 with a U33C and a U25C, empty coal cars going back to Montana. And here you see them. They're the steel gondolas with rotary couplers, and they would haul, basically 100 cars, 10,000 tons, back to Minnesota, Wisconsin, Illinois, Iowa at that time from Montana coal. Now, also after the merger, the train started running through in Minneapolis. So this is 3 SD45s coming in with a block of reefer block of mostly ice reefers, but there's a few mechanicals back here, of fruit from Washington, probably. And so they're heading to Chicago. This picture is I think it's very telling. It's quite I think Greg Smith took this in the early 70s. And this is James J. Hill's Stone Arch Bridge, which was built in 1880. And for trains that weighed probably a few hundred tons, this is mainly for passenger trains because it comes right out of the Minneapolis depot, heading to St. Paul and the passenger mains. And but this is a 10,000-ton coal train heading across the bridge. You can see by the dust, it's probably doing 35, 40 miles an hour across the bridge, and 10,000 tons for a bridge that was built for a few hundred tons. I mean, it was quite a statement about the bridge. The bridge is still there, and it's now a bike path, and it's been kept up, which is really very important. That is the NP.